Welcome to a new video. You may notice that today my voice is a little scratchy, and that is because I'm currently experiencing COVID for my second time in my life. But, after enough of a break, I think I am back to being able to make some videos. And so today's topic is going to be 3.3, the derivative of trig functions. So, a lot of teachers will just show you a graph to, show you why the derivative of sine is cosine and the derivative of cosine is sine. However, there's a more rigorous way for me to show this, and I'm going to use that more rigorous way in today's lesson. So, to start out, we are going to start out by proving that the derivative of sine of x is cosine of x. So, where do we start? Well, with all the derivatives that we proved in the last video, we always start with the definition of the derivative. So f prime of x is equal to the limit as h approaches 0 of sine of x plus h minus sine of x all over h. Alright, what do we do now? Well, we can use some of the formulas that we've learned. So let's see, we can break down this sine using our addition formula. So we're going to say f prime of x is equal to the limit as h approaches 0 of sine of x cosine of h plus cosine of x sine of h minus sine of x. All of that is over h. Well, what can we do with this? We are going to use some of our limit properties and maybe break this down just a little. So we are going to just leave... So we are going to get all those signs together, really. Well, our signs of x's together, rather. So f prime of x is equal to the limit as h approaches 0 of, well, we are going to get our sine of x cosine of h minus sine of x all over h. And we're also going to just break this down into the plus the limit as h approaches 0 of cosine of x sine of h all over h. Alright, what do we do with this? Well, luckily for us, we can factor out a sine of x and a cosine of x out of these two limits. So we're going to say that f prime of x is equal to the limit as h approaches 0. And actually, I'm going to change that to sine of x times by the limit as h approaches 0 of cosine of h minus 1 all over h. Well, what does this really go to? Well, this is actually a special identity that we should know. But this is going to be going to 0. So all of the stuff over here, because this limit goes to 0, this sine of x goes with it. But let's see about this limit as h approaches 0. Well, we bring out the cosine of x, and the limit as h approaches 0 of sine of h over h. This is another important trig, special trig limit. But this one specifically goes to 1. So this is just going to leave us, because everything on over here goes to 0. This limit goes to 1, so we are just left with cosine of x. Alright? What about, how do we show that f of x is equal to cosine of x? Or sorry, f prime of x. Or the derivative of cosine is sine. Alright. Well, or negative sine rather. We once again start out with our definition of our derivative. So f prime of x is equal to the limit as h approaches 0 of cosine of x plus h minus cosine of x all over h. Alright, let's see. Where do we start? So, we are once again going to use some of our formulas, more specifically our addition formulas for cosine. So, f prime of x is going to be equal to the limit as h approaches 0 of cosine of x times by the cosine of y minus the sine of x times by the sine of y all over h. What can we do with this, you may ask? And that is a very good question. Where do we go with this? So we're going to say that we have the limit as h approaches 0, and I'm going to just try breaking this down. So we're going to say that we have cosine of x times by cosine of h over h minus sine of x times by, or yeah, the limit. I want to take the limit, just break this down a bit earlier. Limit as h approaches 0, sine of x, if my pencil will work. And this should be h's up here. Sorry if this is a little bit confusing because I accidentally did h's. So we have sine of h over h. Well, let's see. How can we evaluate this limit over here? Well, as h approaches 0, cosine at 0 is 1. Give me a moment. Okay, I know where I just forgot this cosine of x. So we're going to just bring in this cosine of x over here, and we're going to say we factored it out. So now we get the limit as h approaches 0. This limit, as we already know, goes to 0. So that's just going to be a big ol' 0. 0 minus this limit is going to be sine of x times by the limit as h approaches 0, sine of h over h. This goes to 1, so we are just left with negative sine of x. Alright, let's move on and let's do some problems. So we know the derivative, this is just a product rule derivative, so it's the derivative of the first, negative sine of x, times by the second, times by x squared, plus the derivative, plus the first, cosine of x, times by the derivative of the second, 2x. And that's our answer. For the next one, this is just a constant times by a derivative of sine, which means that this is just going to be negative cosine of x. And finally, we have a quotient rule, so we are going to get negative cosine. Well, we're going to get the derivative of the top, which is going to be sine of x, times by the bottom, e to the x, minus the top, which is going to be negative cosine of x, times by the derivative of the bottom, which is e to the x, all over the bottom squared, which is going to be e to the 2x. Well, after some simplification, we'll get that this is going to be sine of x plus cosine of x all over e to the x. As this, that cancel, and then this negative makes that a positive. Alright, now let's do the derivative of secant and cosecant. Well, we are going to have to start out by, maybe we can do a bit easier. Maybe we don't have to go all the way back to the definition of the derivative. And you would be right. So we can say f prime of x, f of x is going to be a quotient. More specifically, 1 over cosine of x. Well, if that's the case, then f prime of x, what's the derivative of the top? It's 0 times by the bottom, cosine of x, minus the top, which is 1, minus the derivative of the bottom. Cosine of x, that's just negative sine of x, all over the bottom squared, which is cosine of x squared. So then f prime of x must be equal to sine of x over cosine of x, cosine squared of x. In breaking this down, this gives us that f prime of x is equal to sine of x over cosine of x times by 1 over cosine of x. And if that's the case, then this can be broken down into a tangent of x times by a secant of x. And that's our answer. The derivative of secant is tangent secant, or secant tangent more commonly. For the next one, once again, we start out by calling this what it is, which is f of x is going to be 1 over sine of x. Okay. Once again, we're going to use the quotient rule. If you don't know the quotient rule, go back and watch my last video. I also proved the quotient rule, which I find really cool. So f prime of x, then, the derivative of the top, 0 times by the bottom, sine of x, minus the top, which is 1, times by the derivative of the bottom, which is cosine of x, all over sine of x squared. So, let's see, we're going to get f prime of x then is equal to sine of x, because the derivative of, negative sine of x. And then on the denominator we have, we get negative cosine of x. Cosine of x all over sine of x squared. Okay, so then if that's the case, then f prime of x must be equal to negative cosine of x over sine of x times by 1 over sine of x. So for our answer, we get f prime of x is equal to negative cotangent x times by cosecant x. Alright. So now we are going to use some practice problems. The derivative of 4x cubed, that's 12x squared. The derivative of secant, well, that is going to be just secant tangent. Secant x, tangent x. And that's our answer. For our second problem here, we have the derivative of cosecant squared. What we're going to do is, because we don't know the chain rule just yet, we're going to call this cosecant x times by cosecant x. Alright? Well, and we're going to take the derivative of this, which is now a product rule. So we get the derivative of the first, which is negative cosecant x times by tangent x times by the cosecant x plus the derivative of the second, or plus the first, which is going to be cosecant x, times by the derivative of the second, which is negative cosecant x, tangent x. And what we get for our answer is negative cosecant x squared tangent x minus cosecant x squared tangent x, which will finally give us the last result of negative 2 cosecant squared x tangent x. Alright. This last one, we're taking the derivative with respect... Oh, I just realized I technically wrote the wrong notation for all of these. All of these should be with respect to x. Alright, so e, which was what that was supposed to be, e to the x. The derivative of e to the x is e to the x, minus the derivative of cosecant, that's going to be plus cotangent cosecant. Oh, I did that way wrong. Give me a moment. So all of these are supposed to be cotangents. My brain was just like, no, you don't get to do that. Yeah, it happens. And that's a thing. I would really recommend you practice a lot of these and make sure you get the right trig functions as a resultant, because it's very easy for you to mess up. But yeah, we do get cosecants. And just checking our answer up here, yeah, that looks right, doesn't it? Okay. Finally, the last one that we're going to prove is the derivative of tangent and cotangent. So the derivative of tangent, well, f of x in this case is equal to sine of x over cosine of x. Got it? So then this is just a quotient rule. So f prime of x must be equal to the derivative of the top. Well, the derivative of sine is cosine of x times by the bottom, cosine of x, minus the top, which is sine of x, times by the derivative of the bottom, which is negative sine of x, all over cosine of x squared. Well, what you'll see is that this up top is going to become cosine squared, if my pencil wants to write, cosine squared of x plus sine squared of x all over cosine squared of x. And because of one of our trig identities, sine squared plus cosine squared is always equal to 1, we know that this is just equal to f prime of x must be secant squared of x. There we go. Now time to do cotangent. Cotangent is the same thing as cosine of x over sine of x. So what we will see is, as we take the derivative of this, so let's say that we have d over dx of cotangent x, we get the derivative of the top. The derivative of the top is just a negative sine of x times by the bottom, which is sine of x, minus the derivative, or minus the top, which is cosine of x, times by the derivative of the denominator, which is which is sine of x, cosine of x. If I can English, sine of x squared, all over sine of x squared. Well, we can factor out a negative 1 from everything, and we're going to get sine squared of x plus cosine squared of x all over sine squared of x. Well, this, once again, same trig identity, so this is just 1. So we have a negative 1 over sine squared, which another word for that is just negative cosecant of x squared. And there we go. So we now know the derivative of cotangent. The derivative of cotangent. All right. Now I just want us to real quickly fill in the following table. So the derivative of sine is cosine. The derivative of tangent is secant squared. Secant squared of x. The derivative of secant is secant tangent. Secant of x, tangent of x. Cosine of x, the derivative is negative sine of x. The derivative of cotangent is negative cosecant of x squared. The derivative of cosecant is negative cosecant x cotangent x. And isn't that kind of cool? Do you see a pattern? The derivative of all the complementary trig functions all are negative, and all the derivatives of the normal trig functions are positive. That is one tool you can use to help with memorization. And the derivative of any co-function that is not like cosine is like another co-function. All right. Well, now let's talk about these special trig limits that I mentioned earlier. So, one of them is the sine of theta over theta is equal to 1, and the other is the limit as theta approaches 0 of cosine minus 1 over theta is equal to 0. So, I'm not going to prove these today. I'm going to just state these as fact. And later, once we learn L'Hospital's rule, I'll show you a bit more directly of why that's the case. So how do we find the following limits, okay? So if we have the limit as x approaches 0 of sine of 5x over 3x, we don't have a definition for a special trig limit there, but maybe, what if we say that this is 1/3 the limit as x approaches 0 of sine of 5x over x? Well, that's a bit closer, but now we need to get a 5 to make this the x's match. So we'll say 5. We'll pull out the 5 in the numerator to make it 5/3, and this limit now will just approach 1. So now we know that the value of this limit is just 5/3. All right. For the following one, we have the limit as theta approaches 0. What can we do here? We can factor out a 5. So we get 5 times by cosine of theta minus 1 over theta. Well, we can pull out this 5, and this just becomes the limit as theta approaches 0, which is 0. So we get 0. And finally, for this c, we have the limit as x approaches 0. Well, we're going to multiply the denominator and the numerator by 2. So we're going to get 2 over 8. This limit here just goes to 1, so it's equal to 2. All right. Now I have some following functions I'd like us to find the derivative of. The derivative of this first one, try it yourself. Take your time. All right. The answer is going to be 4 cosine of x. The derivative of sine is cosine. Plus 3, the derivative of cosine is sine of x. All right. But it's negative, so we also need to make sure that we do negative. This down here is a product rule, okay? But I'm going to do something really neat, and I'm just going to call this 8 sine cosine. All right, so now if I take the derivative of that, d over d theta, the derivative of the first is going to be 8 cosine of theta times by cosine of theta. Well, once we get to the second, so plus, well, we have 8 sine of x, or sine of theta, times by the derivative of the second, which is going to be negative sine of x, or sine of theta. So what we're left with is d theta of f of theta is equal to 8 cosine squared of theta minus 8 sine squared of theta. Which we can't really do much more with that. Alright, what else can we... Alright, so for this next one... So for this next problem, we have f of t is tangent of t over e of t. We're going to take the derivative with respect to t. So this is going to give us something on the lines of the derivative of tangent. Well, that's just secant squared of t times by e of to the power of t minus tangent of t. Alright. All over e to the, or times by e to the t. All over e to the 2t. Well, this 2 will cancel with all of those e to the t, so we're just left with secant squared of t minus tangent of t all over e to the t. Alright, now time for this last one. This one's kind of challenging because we have 3 derivatives multiplied together. So what we're going to do is we're going to define this as our f, and we're going to say that this is going to be our g. So we're going to take the derivative first of f of x. So the derivative of f of x in this case is going to be e to the t plus t e to the t times by the second, which is just tangent of t, plus the first function, which is t e to the t, and then times that by the derivative of tangent, which is just secant squared of t. Even though this function was supposed to be in terms of w. Apparently, I just really like my t's and my x's more than my thetas or anything else like that. Alright. Now, I don't think this is going to become very much simpler, so I'm just going to leave that as is. So, let's see. We have an object with a weight W being dragged along a horizontal plane by a force acting along a rope attached to the object. If the rope makes an angle theta with the plane, then the magnitude of the force is equal to mu times by the weight all over mu sine of theta plus cosine of theta. So we want to find the derivative of force with respect to theta. Well, in this case, well, then df d theta, well, then the numerator, the derivative of the numerator is 0 times by the denominator, mu sine theta plus cosine theta. Alright, minus, well, we have mu weight times by mu cosine theta. The derivative of sine is cosine, minus sine theta, all over mu sine theta. Alright. Sine theta plus cosine theta. All of that squared. Alright, what are we going to do with this? Well, this here is just 0. So we are left with negative mu. Let's see. Do I want to yeah, sure, why not? We'll expand it out. Mu squared weight cosine theta minus mu weight sine theta Let's see, does that help at all? No, it does not. Okay. So let's see, we're going to put this over mu sine theta plus cosine theta squared. Well, now we need to solve this for 0, and that's our derivative. You know what? Actually, there is one thing we can do. Actually, no, I did that wrong. There we go. But we can't really do anything here. But we're going to solve this for 0. So we want mu w cosine of theta plus mu w sine theta to be equal to 0. And we don't care about the denominator since that can't be equal to 0. So if we subtract this mu to the other side, so we are going to get, and this needs to be a negative, so we're going to say mu squared w cosine of theta plot is equal to mu sine theta. Well, let's see. We can divide out a mu, so we get mu of mu is equal to w, and there's a w over here, so that w and that w actually both cancel. So cosine theta is equal to sine theta. What else can we do? Well, I'm going to subtract this cosine over. Mu times cosine of theta minus sine theta is equal to 0. Well, when will that happen? Well, there's not really a set way to solve for mu in this case. But we do have an expression where if we want 0, then we can solve for 0. But that's probably as good of an answer as we're going to get. Alright, and now I just really have one last problem for us today. And it's to find the 99th derivative of sine of x. So, this is going to be a challenge, you know. The derivative of sine once is equal to cosine. The derivative of sine twice is going to be negative sine. The derivative of negative sine, or for the third time, is equal to negative cosine of x. And finally, the derivative of negative cosine is equal to sine. Well, what if we don't... We know this pattern is going to repeat indefinitely. So if we are at 100, so we're going to be 25 rounds of this derivative, so we just need to go to one before, and we would see that this would be negative cosine of x. And that's it for you. I hope y'all found this video informative and enjoyed. I hope y'all will have a great rest of your day. Bye-bye.